Permutations of different objects. This formula is on your formula sheet, and I'm going to tell you that we're hardly ever going to use it. But it says the number of distinct permutations of n objects taken r at a time. And when it's said that way, it makes hardly any sense. But we'll go to an example and see what this looks like. So here's example 2. And the reason we're not going to use this formula very much is because we can just instead of doing the formula, we can use our decisions and our choices just as easily. So 8 students are competing in a 200-meter race. How many ways can they finish first, second, and third? Well, you have a decision. Who could come in first? A decision, who could come in second, and who could come in third. We really don't care about 4, 5, 6, 7, and 8 because they're not going to get a medal, right? So it's like, yeah, whatever. First, second, and third is going to be important. How many people could come in first? Right? Any of the 8 could come in first. Even if they're like the slowest person, like lightning could strike the other ones. That's kind of hard. Yeah, maybe we should not think that way. But anybody could come in first. Think of a more pleasant reason why. And then how many people could come in second? 7. And then 6. This is how we would normally do this question. We have decisions, we have choices, it's pretty easy. This is the same as 8p3. And your formula for NPR on your formula sheet says n factorial over n minus r factorial. So let's look at how this formula works. Okay? 8p3 would tell us that we should have, let's move it over here a little bit. According to the formula, 8 factorial on the top and 8 minus 3 factorial on the bottom, which is the same as 8 factorial over 5 factorial. And we're going to have to do mental math with factorials. And I'm not going to expect you to know that 8 factorial is 40,320. And then have to divide that by 120 and figure out what that is. Instead, what we're going to do is we're going to use the definition of factorial and say, I know that 8 factorial means 8 times 7 times 6 times 5, all the way down. So I start with the biggest number that I see, which is the 8. And I keep going down until I get to 5, and then I say, oh, why don't I just put an exclamation mark to say it should keep on going, but because I have a 5 factorial on the bottom, it would cancel out. And you see that you just get the 8, the 7, and the 6, the same that we had with our decision. So in this formula, we can always translate back and forth between these. This is your number of spaces or your number of decisions. And this number in the space is the number of choices you have to start with. But your choices always go down by 1 because someone gets used up, right? You can't have this. How long of a race is this? 200-meter race. You can't have the first person finish first, second, and third all at the same time. I guess technically it goes on a round track. They could round, come first, run all the way around again, and then still come in second. That would be very hard to do, though, because then you're, no, I don't think that's allowed. Kind of fun to watch. Okay, questions for practice? 4, 6, 7,